Welcome to Quick Science. I'm Robert Brown, and today we're going to do an experiment that will demonstrate a couple of different scientific principles. What you'll need if you want to do this experiment at home along with us is a pan, a candle. This candle is a tall candle, but a shorter candle, like a tea candle, should work just fine. A glass jar, and we want a glass jar that's big enough so that there's room when you put the glass jar over the candle. There's a lot of space between the top of the candle and the bottom of the jar. You'll need some water, and I've put some food coloring in the water. That's just to make it easier for you to see at home what happens. It's really not necessary for the experiment. And some matches. Now, since this science demonstration involves using matches, you'll need to have an adult with you when you do this experiment, just to make sure everyone stays safe. Let's put on our safety glasses now and get started. First, you'll fill your pan with water, which I've already done, and about a half inch, quarter inch deep will do. I've added some food coloring, as I said, to make it easier to see. You want to place your candle in the middle of the pan, right like that. Then I'm going to light the candle. So I take a match. I'm going to light the candle. There we go. Now I want to make sure the match is completely out. I'm going to dip it in the water there just to make sure it's completely out before I set it aside. That's just to be safe. I'm lit the candle, and I'm going to place the glass jar over top of the candle. Now let's watch and see what happens. Okay, I've placed the jar over the candle, and we can see the candle's burning just fine inside. Everything's looking good. Now you'll begin to notice the candle doesn't seem to be as bright anymore, does it? It's getting darker, getting dimmer, and the candle flame is going out. And when it goes out, look what happens to the water level inside the jar. It's gone up, hasn't it? Now, so first, what happened when you place the lit candle under the glass jar? When something burns, it needs oxygen. The candle flame is taking oxygen out of the inside of the jar, right here, in a process that's called combustion. It also gives off some carbon byproducts like carbon dioxide, carbon monoxide, some tiny particles we call particulates. That would be like the soot that you get, and water vapor that condenses on the inside of the jar. You can see here the water vapor that's condensed on the jar. What this all means is that there's less air inside the jar than outside the jar once the oxygen is all used up. So the air pressure inside the jar goes down, it goes lower. But the candle flame also did something else. It heats the air inside the jar. So while the candle is burning, the air inside the jar is warmer, and warmer air expands. This is Charles's law, which simply states warmer gases tend to expand and take up more volume, while cooler gases contract as they cool and take up less volume. The combustion process leaves less atmosphere inside the glass, but the warming means that even though there's less air, it expands out and keeps the air pressure fairly constant. Now, once the oxygen was used up, combustion could no longer happen, so the candle flame went out. With no source of extra heat, the air begins to cool, and cooler air takes up less space than the warm air. This lowers the air pressure inside the jar. Now, the air pressure pressing down on the surface of the water outside the jar is greater than the pressure pressing down on the water inside the jar. So the air pressing on the water outside the jar forces the water to rise up inside the jar to fill the void left by the air as it cools and contracts. And that's why the water level rose inside the jar. And that does it for this episode. Until next time, stay safe.